Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P1157 relates to the air-fuel AF sensor, specifically signaling a high voltage in the circuit associated with sensor 1. This sensor's primary role is to monitor the air-fuel mixture entering the engine, which is crucial for optimal combustion and reduction of emissions. The AF sensor is typically located in the exhaust system just before the catalytic converter, allowing it to accurately assess the composition of exhaust gases. When this sensor detects an unusual high voltage, it indicates a potential issue in the circuit that may lead to improper fuel mixture, affecting engine performance and emissions control. The Engine Control Module, ECM, analyzes this information to adjust fuel delivery accordingly. It is vital to address this DTC promptly to ensure the vehicle runs efficiently and meets environmental standards. The AF, Air Fuel Sensor 1, plays a vital role in ensuring the engine runs efficiently by monitoring the ratio of air to fuel entering the combustion chamber. Located strategically in the exhaust system right before the catalytic converter, it enables real-time data on exhaust gas composition. This data is then relayed to the Engine Control Module, ECM, which adjusts fuel injection and ignition timing accordingly. When the DTC P1157 is triggered, the sensor signals that there's an abnormally high voltage present within its circuit. This malfunction could hinder the engine's ability to achieve optimal fuel economy and increase harmful emissions. Thus, understanding this component's functionality and location is crucial for effective troubleshooting and repair. There are several potential causes for the DTC P1157. First, the AF sensor itself might be faulty, possibly due to age, exposure to heat, or other environmental factors. A malfunctioning sensor will likely give incorrect readings and thus trigger this error code. Another likely culprit is issues with the wiring connected to the sensor or the Engine Control Module, ECM. Damaged, corroded, and complex, or disconnected wires can create voltage fluctuations, leading to high voltage errors. Finally, a malfunctioning ECM can also create misleading data and trigger the DTC. Understanding these causes aids in effectively pinpointing the root of the problem. When DTC P1157 is present, several symptoms might become evident. One of the most immediate signs is poor engine performance, which may manifest as a lack of power, rough idling, or stalling, as the air-fuel mixture is not correctly balanced. In addition, you may notice increased emissions, as a faulty sensor can lead to improper combustion. This could eventually cause failure in emissions testing, leading to further complications. Another clear symptom is the illumination of the check engine light on the dashboard, alerting the driver to a potential issue. Recognizing these symptoms can provide important initial clues that assist in further diagnostics and repairs. The first step in troubleshooting DTC P1157 involves turning the ignition switch to the on position. This action powers up the vehicle's electronics without starting the engine. Before proceeding, it is important to record all freeze data and any onboard snapshots available through the diagnostic tool, HDS. Freeze data refers to the information captured when a fault occurs, helping technicians understand the conditions that led to the issue. Additionally, reviewing general troubleshooting information ensures that no fundamental steps are overlooked. This thorough approach sets the foundation for effective diagnostics. In this step, you will clear the DTC using the Honda Diagnostic System, HDS. Clearing the code removes any logged faults, allowing you to reset the system for a fresh evaluation. After clearing the code, start the engine and let it idle for 1 minute. This idle time allows the vehicle's systems to stabilize and any potential faults that may reoccur to present themselves. Waiting ensures that any intermittent issues are equally evaluated during this period. This process is vital in determining if the issue is persistent or momentary. After running the engine for a minute, check for any pending or confirmed DTCs using the HDS. A pending DTC is an indication that a fault was detected but did not trigger a check engine light just yet. Confirmed DTCs, on the other hand, signal that a fault is actively impacting vehicle performance and has illuminated the check engine light. If DTC P1157 is still indicated, it confirms that the problem persists, warranting further investigation. However, if it is not indicated, it suggests an intermittent failure, suggesting the underlying system is okay for the moment. Intermittent failures can sometimes indicate poor connections, loose terminals, or wiring issues that will need to be checked next. Next, turn the ignition switch to the lock, 0 position, ensuring that the vehicle is fully powered down before proceeding. This is an important safety step to prevent any electrical shorts while working on the vehicle's wiring. After that, you need to jump the SCS, Service Check Signal line, with the HDS. This action places the system in a diagnostic mode. Following this, disconnect the A-factor sensor, Sensor 1, 4P connector from its harness. Performing these steps ensures that you can safely check the continuity of the wiring without interference from the sensor or the ECM. In this crucial step, disconnect the ECM-PCM connector C, which typically contains 49 pins. This allows access to the terminals for further checks. Next, you will need to check for continuity between the AF sensor, Sensor 1, 4P connector terminal number 1, and ECM-PCM connector terminal C29. Continuity testing checks whether an electrical path exists without interruption. If continuity exists, it indicates the wiring from the AF sensor to the ECM is intact. If there is no continuity, it suggests an open circuit or damage in the wiring, which must be repaired before moving forward. You will now perform a continuity check on AFAT sensor, Sensor 1, 4P connector terminal number 2, and ECM-PCM connector terminal C30. This terminal connects the negative side of the sensor's signal circuit to the ECM. Establishing continuity confirms that this circuit is functioning properly, which is essential for the sensor to relay accurate data to the ECM. If continuity is confirmed, the examination can advance to the next phase of diagnostics. Should you find no continuity, this indicates a fault in the wiring, and repairs must occur before testing further. Each step in this process is vital for isolating the problem effectively. For final repair verification, you'll want to reassemble any components that were disconnected during troubleshooting. Once everything is put back together, clear the Diagnostic Trouble Code DTC with the HDS to reset the system. After clearing the code, take the vehicle for a test drive to ensure that the issues have been resolved. Pay close attention to whether the check engine light comes back on and whether the vehicle behaves as expected under various driving conditions. This step is crucial in confirming that the repairs made have effectively resolved the problem without introducing new issues. A successful test drive will showcase that the AF sensor and its circuit are functioning correctly. Preventive maintenance plays a crucial role in prolonging the life of automotive components like the AF sensor and the associated wiring. Regular inspections of the sensors can catch any wear or tear before it escalates into a costly repair. Checking for cable damage, such as frays or corrosion, is essential in vehicles operating under various environmental conditions. Furthermore, keeping electrical connections clean and secure can prevent issues related to intermittent failures caused by poor contact. Maintaining the electrical system not only aids in improving vehicle performance, but also minimizes the risk of repeated diagnostic trouble codes. In conclusion, DTC P1157 is a crucial indicator that the air-fuel sensor is experiencing high-voltage conditions within its circuit. This DTC highlights the importance of monitoring the air-fuel mixture, which affects both engine performance and emissions. Proper troubleshooting involves a systematic approach, from checking continuity in the wiring to inspecting the AF sensor and ECM. Understanding possible causes and symptoms associated with this code allows technicians to make informed decisions leading to effective repairs. Moreover, regular preventive maintenance practices can mitigate future occurrences. Addressing and resolving this DTC is essential for ensuring your Honda Accord remains performant and compliant with environmental regulations. Please like and subscribe to the channel. See you next time.